This is question 26 from the GATE 2016 session 2 EC paper, where we are given this ordinary differential equation in x and t with x of 0 equal to 1 as the initial condition, and we are asked to find out if it has to be solved by forward Euler method, what is the largest time step that can be used without making it unstable, without making the numerical solution unstable. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. So the only background that you will need to know for this method is the way forward Euler is done, right? So if you have an ordinary differential equation of this form, dx by dt is equal to f of x comma t, then forward Euler will give the solution in this approximate manner. You have to iterate over I. For example, if you start with I equal to 0, x1 is equal to x naught plus delta of t into f of x naught comma t naught. Similarly, x2 is x1 plus delta of t into f of x1 comma t1, and so forth, right? And as I tends to infinity, you will get the solution for all time. So let's solve this question first exactly before we solve it via forward Euler to figure out the largest time step. So in the exact solution, we can get that dx by minus 3 common into x minus 2 by 3 is equal to integral over dt, right? And this, if you work it out, comes minus 1 over 3 ln of x minus 2 by 3 is t plus c, and so you will get x is 2 by 3 plus exponential of minus 3t plus c. This will look like the following curve. Right? So this is the exact solution. As t tends to infinity, we will get it with this term will disappear and you will only be left with 2 by 3. So now we'll solve it via forward Euler. X of I plus 1 is equal to x of I plus delta of t into f of xi comma ti, right? What this means is x of I plus 1 is equal to x of I plus delta t times minus 3xi plus 2, right? I'm just substituting for the f in our expression. X of I plus 1 is, now if I take xi common, this will be 1 minus 3 delta t plus an extra 2 delta t term. And you can see that this is the term that multiplies with xi for each forward Euler iteration, right? And for m is equal to minus 1, this will be oscillatory, right? That is verging on stability. This is 1 minus 3 delta t is equal to minus 1, which means delta t is minus 2 by 3, which is approximately 0.667. The answer is 0.667.